Hey everybody, we are working on 7.5, which is using proportional relationships. So the big thing here has to do with indirect measurement. It's essentially using similar figures or proportions or drawings or any way other than literally measuring something to find out a measurement. And so there's 5 word problems in this section. There's one on each slide, one here, one here, 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 and here. Not all word problems, but those are the ones that we're going to want to be able to do. So this is the only other one that might be a little bit confusing. We'll get there in a second. But if you try most of this out, even at the beginning, and you know how to do all of it, then go for it. And you might be doing this a little bit quicker than I do here in the video. So, but if not, just you can watch along and see how I do it, and hopefully it makes a little bit of sense. So again, indirect measurement is using scale, figures, similar figures, proportions, to measure something. So in this first example, you can see that we're going to do just that. You've got a person standing here, and we create a similar triangle. So in order to do this in real life, you'd have to stand outside, and you'd actually measure this angle, and you would make sure that this angle was the same. And then you would be able to measure the height of a flagpole or anything that's as tall as you want, because you would know that the triangles are similar by angle. So this is a real way that people used to measure anything that was too tall to like actually hold up a ruler or a tape measure and measure. Now there's electronics and stuff that use these angles to do it, but you can do it very easily in your backyard to see how tall a tree is. I mean, it's not anything that's too hard to do. So anyways, we'll set up a proportion here. So I take it for granted that I think you can see which parts of the triangles are going to be similar to each other. These two bottoms, 5 feet over 14 feet 2 inches, which is 14 and 2/12 inches. Sorry, 14 and 2/12 feet. And that should be equal to the height of this person, which is 5'6", which is my height, and the height of this flagpole, which we don't know yet. So that's what we're going to need to let our variable be. So doing that, I can set up 5 feet 6 inches, which is 5.5 feet, over the total, which I don't know yet. We'll just say x feet. So all of our units are in feet here, so we don't have to worry about that. So I'll go ahead and solve this. So if you cross multiply, 5x equals 14 and 2/12, whatever that is, times 5.5. And if I divide that by 5, I should be able to get an answer for this. So I can take out my, I don't mean to cover that up. Let's get rid of that. So if I take out my graphing calculator, and let's not ruin everything here. All right. So you can follow along and see what I do. Let's clear out that stuff from Algebra 2. No? We're not going to clear? All right. Let's get our regular old calculator out. This thing will do just fine. So 14 and 2/12 is 14 plus 2/12. So 14 and that. I have to multiply that by 5.5. And I have to divide that by 5. So that looks like it's 3.16, which doesn't seem to make a lot of sense. So I must have hit something wrong. You might have noticed as we went along. So I have to multiply by 5.5 and divide by 5. That makes a little bit more sense. I don't know what I did wrong there, but so 15.583 feet. So yeah, anytime you get an answer that doesn't make sense, try it out and try it again, see what happens. So 0.583, I want to know what that is in inches, so I'll take just that part, and I'll multiply it by 12. I mean, you can, do all the 3's you want. It doesn't matter, as long as you get it to the nearest inch, which obviously is 7 inches. So that would be 15 feet and 7 inches. So you might have done something like this already. So this is just an example of indirect measurement. If you knew how to do this already, then fine. That shows how you do that. So moving on to the next one, actually creating a scale drawing. So this is going to be a little bit tough to do on a video. So I asked that if you know how to do the measurements, you at least go to the end of this slide and see how I draw the picture. So I've got to set up proportions for a scale drawing here of the Lincoln Memorial. So these are the actual measurements of it in meters. So it says make a scale drawing, just like on the penny. That's a scale drawing. It's a scale. I don't know that it's a drawing. You press a penny, but so a scale engraving really. But for us, we're just going to draw a picture or a drawing of this. So it's 57 feet long and 36 meters wide. So I'm going to use this scale right here to figure out what that is. So let's get what do I've got? I've got length first, I'll do. So I've got 57 meters long. 57 meters long over, well, I don't know how many meters long it's going to be. And then when I do this scale, this is going to be the part that's longer. And this is going to be the part that's shorter. So when you look over at the part that I've already set up, this is the long part, this is the short part. So when I go to set up the right side, I know that the long part is going to have to be on top, and the short part, which is 1 centimeter, is going to have to be on the bottom. So the one on the left should be in centimeters. So you'll notice that I'm in meters on some of it, and I'm in centimeters in part of it. And I'll show you how those drop out so that you can see that I'm not ignoring the fact that the units are different. So when I cross multiply, I get 57 meters times 1 centimeter equals 15 meters times x centimeters. And then when I divide by 15 meters, if you look at the units, meters cancel, and you're left with just centimeters on this side and centimeters on that side. So it shows exactly how the units are supposed to be like that. So I end up with x equals, if you do the division, you should get 3.8 centimeters. Just do that on the calculator. So that's my part in the centimeters. So you'll notice that I essentially took this larger number and divided it by the scale because it was just 1 to 15. So I'm just going to do that for the second one. I don't need to set up this whole big proportion if I notice that I should be able to take 36 meters and just divide it by 15 meters, which is in 1 centimeter, and just get the other answer of 2.4. There's nothing wrong with doing it that way. So if you've been doing it that way, that's fine. So it looks like that 3.8 by 2.4 is correct. So the other part where you have to make a scale drawing is literally where you take out a ruler and you draw it. So in my case, and I haven't really used the ruler in here too much before, so I'm going to try. So 3.8 would be starting here and going out. 3.8, which would be about here-ish. I know that I went a little bit more. I did 3.9. So 3.8. And then the other part on my ruler, I got to rotate this somehow. So oh, that makes it bigger and smaller. So can I rotate it? Well, I'm not going to waste your time trying to rotate it here. I'm not exactly sure how to flip it around. But you can see that I drew that one at 3.8 centimeters. And then you would take your ruler and you would turn it sideways, which I can't do because, I'm not smart. So, and you should be able to turn it into the other one, which if you did it this way, I'm eyeballing it, would be about 2.4. So you could take your ruler and do that. So that, when you connect it, would be a scale drawing of the Lincoln Memorial. And here's Mr. Lincoln. He's got a top hat. He's got a beard. So there's him. But anyways, that's how you do that. So scale drawing, there's going to be ones where we do that in 7.5 and 7.6 as we move forward. So moving on to this. This is one you want to put a big star next to because I know that this kind of question pops up on your midterm later on. So make sure that you know how to do this and you know the shortcuts. It says find the scale factor and the ratios of the perimeter in the area. Scale factor is essentially how many times bigger or smaller something is than something else. So I can write that down up here. So it's how many times bigger or smaller something is. than something else. So when I find a scale factor, if I found the scale factor from, here, let's label these. So if I was going to do the scale factor from A, B, C to D, E, F, that literally means if I wanted to go from a figure this size, the size of A, B, C, and go down to something smaller, what would I multiply it by? So if I look at the ratio of all the sides here, so if I look at one that's like 9:3, or, oops, sorry. So if I want to go from ABC to DEF, and I want to get smaller, I have to look at like the ratio the other way. So 3/9 or 5/15, those are all 1/3. So if I want to go from ABC, which is large, to DEF, which is small, I have to multiply by a fraction to make it smaller. So the scale factor from ABC to DEF is 1/3. If I wanted the scale factor from DEF to ABC, then that would be the other way around. So like 9/3 or 12/4. That comes out to 3, which makes sense because if you wanted to take something like DEF, which is small, and make it bigger, which is something like ABC, I would have to multiply that by a larger number, which is where I get 3 from. So that's where that comes from. If you look at the scale factor of the areas, which is the second part it asks us, so we did that for the perimeter, we did it for the one side to another side. Then that works out the same for the perimeters. So these scales also work for the perimeter. So to show you an example, the perimeter of this figure, 9 plus 15 is 24. 24 and 12 is 36. If I look at the perimeter of this smaller figure, 3 and 5 is 8. 8 and 4 is 12. If you take 36, which is the perimeter of A, B, C, and you divide it by the perimeter of D, E, F, which is 12, you end up with 3, which makes sense because it's the same one that's down there. So that makes sense because one side to one side is 3, so the large side, the whole 3 sides together to all 3 smaller sides should be the same thing. So the areas are a little bit different. If I calculate the area of this triangle, which is 1/2 the base times the height, that's 1/2 the base times the height. Half of 12 is 6. 6 times 9 is 54 units squared. If I do that with the one here, half the base times the height, which is area, by the way. Half of 4 is 2. 2 times 3 is 6. So if you wanted to find the scale factor of the areas, if you look at 54 divided by 6 to get the scale factor, that would be 9. If you notice, that's 3 squared. So it's just this scale factor squared, which makes sense because area is square units. If you look at the scale factor of the areas in the other direction, so you do it from the small one to the larger one, you end up with 1/9, which, if you notice, is just 1/3 squared, which you get from the other one. So the shortcut you can do is you just square whatever the scale factor is, and you don't have to do it. So that's how you get the scale factor. So over here, when I did the answers, I did the scale factor from the smaller one to the bigger one. If you did it from the bigger one to the smaller one, it also works out. So it just depends what the question's asking for. If you scroll down, I've got another example here, and you can try it, and you can look at the scale factor of the perimeters and the areas. But to show you how you might use this, I think there's an example here that I want to show you about. So if this one made sense and you're good, move on. If you want to try the second one and see if you can get it to match up and show that that's true, do that. I'm going to move on to the next one over here to show an example. So if I wanted to do the scale factor from these two, this question's asking me, it gives me the area of ABC. This area is 24 meters squared. I want to find the area of the larger one, so I want to find the area of this guy. Now, I can find the scale factor because I'm told that they're similar, And I can also use the fact that I already know what these numbers are. So the scale factor of the smaller one to the bigger one looks like it's going to be 15/10, which is 3/2. So that's the scale factor of the small triangle to the big triangle. The scale factor of the areas should be that same thing squared, which is 9/4. Okay, not so bad. So I found the scale factor of the areas. If I take the small triangle area times 9/4, I should get the big triangle's area. That's what a scale factor helps you do. So the small triangle's area is 24. If I multiply that, it's 24 meters squared, I should say. If I multiply that by 9/4, I should get the area of the big triangle. So something about notation, just so you know, when you write a large letter or something and you put a little subscript underneath, it's a way to show notation in math without having to write all the stuff out. So when I write A, big triangle, it means area of big triangle. So anyways, 24 times 9/4, the 24 and the 4 cancel. 6 times 9 is 54. So I get 54 meters squared equals the area of the larger triangle, which is that answer there. So I have time to do the last one. We're already up to 16 minutes, so you can try. There's another question after this that has to do. It's more of a challenging question. It's just the numbers are bigger. It's not really that bad to actually do out. I have the answers here. You can try it. If not, you can try it in class, or I have some other word problems. But I try to make these short in case you have to pause or go back or anything. So I'm going to skip that last problem. So if you want to do it, you can, and if not, you're good to go.